Dear students, in this class, let us discuss about an important theorem which is known as Bolzano-Weierstrass theorem. So the theorem states that a bounded sequence of real numbers has a convergent subsequence. Bolzano-Weierstrass theorem, the statement is a bounded sequence of real numbers means let x be a proof is let x be a x equals xn be a sequence of real numbers which is bounded, means it is bounded both bounded above and bounded below. X equals xn be the sequence of real numbers which is bounded. Then the theorem states that this x has a convergent subsequence. So x equals xn be a, its proof is x equals xn be a sequence of real numbers. Suppose it is bounded. Then the sequence xn has this x has a monotone subsequence. Why? By the monotone subsequence theorem. So let x and k be the monotone subsequence of the sequence x. Let x and k be the monotone subsequence of the sequence x. Let it be x dash. Then x dash is bounded. Why x dash is bounded? Why? Because x is bounded. X dash is bounded because x is bounded. Means x dash is so as x dash is bounded because x is bounded. That means x dash is a bounded monotone subsequence of x. Hence x dash is convergent. X dash is convergent. That means sequence x and k is convergent. That means sequence x has a convergent subsequence. Agreed? X equals xn be the sequence of bounded sequence of real numbers. That x dash is sequence x and k be its subsequence. Then since x is bounded, x dash is bounded. Then x dash is a bounded monotone subsequence. So x dash is a bounded monotone sequence. That means by monotone convergence theorem, x dash is convergent. What is x dash? It is a subsequence of x. Then x has a convergent subsequence. So this is monotone converges. So this is Bolzano-Weierstrass theorem. So the theorem states that every bounded sequence of real numbers has a convergent subsequence. So it's an important theorem. Okay. Now come to another result. Let x equals xn. Let x equals xn be a sequence of real numbers. And let x of r, x is any real number, x of r, x is any real number, has the property that every convergent subsequence of x converges to this small x, then the sequence x converges to x. X equals xn be the sequence of real numbers, x is any real number. Then if every subsequence of x has it is converges to small x fallen on, then x converges to x itself. Its proof is let x equals sequence xn be a sequence of real numbers. Then it is x equals xn is sequence of real numbers which is bounded. Agree? That is by the hypothesis. Which is bounded means there exists some m positive such that modulus of xn strictly less than m. Modulus of xn strictly less than m or as capital M, whatever may be. So there exists capital M such that modulus of xn less than or equals m for all n fallen n. Agreed? Sequence xn is bounded, then by the definition of boundedness there exists a real number m such that modulus of xn less than or equals m for all n fallen n. Now to prove the sequence x means x equals sequence xn converges to x. This is the requirement. Sequence xn converges to x. If possible, sequence xn does not converges to x. If possible, sequence xn does not converges to x. Then what happens? Since sequence xn does not converges to x, there exists a subsequence x and k of x. There exists a subsequence x and k of x which does not converge to x. That means for all epsilon positive, there exists for all epsilon is positive, there exists a subsequence xnk of that one, xnk of x such that modulus of xnk minus x greater than or equals epsilon naught. Agreed? Or epsilon for all k fallen n. Enough? Okay. Since why? Because sequence, we assume that sequence xn does not converge to x, therefore there exists a subsequence xnk of x which does not converge to x, means for all epsilon naught is positive, modulus of xnk minus x greater than or equals epsilon naught for all k fallen n. For all k fallen n. But x dash is a subsequent. What is x dash? Let x dash is, let x dash equals sequence xnk. But what is x dash? X dash is a subsequence of x. Okay, x dash is a subsequence of x. But what is x? X is bounded. Since x is bounded, we know that x dash is bounded. When x is bounded, x dash is bounded. Therefore, x dash has a convergent subsequence by monotone subsequence theorem. So since x dash is bounded, then x dash has a convergent subsequence. Let it be x2 dash. Let it be x2 dash. Then, since x2 dash be a convergent x2 dash be a convergent subsequence of x dash, means x2 dash is convergent. Okay, x2 dash is convergent means x2 dash is converges to where? X2 dash is converges to x. That's a contradiction. By the contradiction to this argument, this contradiction is due to our wrong assumption that means sequence xn means x is convergent. Okay. If sequence xn be a sequence of bounded sequence of real numbers, then if x is in R such that every subsequence of x converges to that x, then the given sequence x is also converges. Agree? Okay. That means if every subsequence of a bounded sequence converges to a particular point, then the given sequence also converges to that limit. That is the conclusion. If a bounded sequence of real numbers has number of convergent subsequence which converges to a particular point, then the original sequence also converges to that particular point itself. Agree? Now, let x equals xn has a subsequence. Let x, consider sequence x equals, let's consider sequence x equals xn be a sequence that converges to 0. Xn converges to 0. Then prove that limit x equals 0. Limit x equals 0. Then to prove that limit x equals 0. How? Proof is, if possible, limit x differs from 0. What happens? Limit x differs from 0 means there exists, limit x differs from 0 means there exists epsilon naught is positive such that for all n greater than 0, there exists nk greater than n such that mod x is with the modulus of xnk minus 0 equals modulus of xnk. Modulus of xnk minus 0 means modulus of xnk. So, modulus of xnk greater than or equals some epsilon naught. Listen, sequence xn be a sequence of real numbers, and that x equals xn has a subsequence that converges to 0. Means, if the problem is that x equals xn be a sequence of real numbers, then every subsequence xnk of x, every subsequence of this xn converges to 0, then to show that limit x equals 0. Every subsequence of this x converges to 0, then to show that limit x equals 0. That's nothing but a corollary of the previous result. Previous result says that if for any bounded sequence of real numbers and every subsequence of that sequence converges to a particular point x, then the original sequence also converges to x. Here we try to prove that let xn be a sequence of real numbers and every subsequence of xn converges to 0, then we try to prove limit x equals 0. If possible limit x differs from 0, then there exists some epsilon naught with a nk greater than n such that mod xnk does not converge to that. That is mod xnk equals mod xnk minus 0 greater than or equals epsilon naught. Agreed. Let y1 equals xnk. Let y1 equals xnk such that nk plus 1 greater than nk plus 1 greater than nk with the modulus of x nk plus 1 minus 0 equals modulus of x nk plus 1, that is greater than or equals epsilon naught. Agreed. Choose y2. y2 equals xnk plus 1 such that nk plus 2 greater than nk plus 1 with the modulus of x nk plus 2 minus 0 equals modulus of x nk plus 2 greater than or equals epsilon naught. Proceeding like this, there exists a subsequence yn of the sequence xn such that the subsequence yn does not converge to 0. Yes, that's a contradiction. This contradiction is a contradiction to the fact that the subsequence converges to 0. This contradiction is due to our wrong assumption. Therefore, limit x equals 0 itself. Agree. Now, come to another example. Let xn greater than or equals 0. Consider this example. Let xn greater than or equals 0 for all n fallen n. For all n fallen n. And the limit minus 1 power n xn exists. Limit of minus 1 power n xn exists. Then prove that secant xn converges. Prove that secant xn converges. How? Proof is xn greater than or equals 0 for all n fallen n and limit minus 1 power n xn. Limit of the sequence minus 1 power n xn exists, then prove that xn converges. So it is given, let x equals xn be a sequence of real numbers with xn greater than or equals 0. Limit minus 1 power n xn exists means let it be L. Let the limit minus 1 power n xn equals L. So that means for all epsilon positive, there exists n fallen n such that modulus of minus 1 power n xn minus L strictly less than epsilon for all n greater than or equals n, or for all n greater than or equals s capital E. Agree. So that means epsilon strictly greater than modulus of minus 1 power n xn minus L. Epsilon greater than modulus of minus 1 power n xn minus L. So it is greater than or equals modulus of minus 1 power n xn minus mod L. Why? Because we know that the result modulus of mod x minus mod y, modulus of mod x minus mod y less than or equals modulus of x minus y. Agree. So it equals, what is modulus of minus 1 power n xn? It is mod xn because it is simply xn. Why? Because xn is greater than or equals 0. Therefore it is modulus of xn minus L. Enough. Modulus of xn minus mod L. Yes, modulus of xn minus mod L. That means modulus of xn minus mod L less than epsilon for all n greater than or equals some n itself. That means limit xn equals mod l. So limit xn equals mod l means secants xn converges. That is what we are reducing. Agree? Okay. Now come to a problem. Evaluate the limit 3n, find the limit 3n all power 1 by 2n. Evaluate the limit 3n all power 1 by 2. How? We know that. What about limit n power 1 by n? We know that limit n power 1 by n equals 1. Agree? Then, for any subsequence of when limit n power 1 by n equals 1 means, then we know that if xn is the given sequence n power 1 by n, if xn converges to a particular limit, then every subsequence of xn converges to that limit. Agree? Okay. Therefore, every subsequence of n power 1 by n also converges to 1. Enough? Okay. Now, what about the limit? Therefore, limit 3n, limit n power 1 by n equals 1. Therefore, limit 3n all power 1 by 3n is also 1 itself. Enough? So, limit 3n all power 1 by 2n equals, what do you get? Limit 3n all power 1 by 2n equals limit 3n all power 1 by 3n. Okay, limit 3n all power 1 by 3n all power 3 by 2. Sure? Limit 3n all power 1 by 2n equals limit 3n all power 1 by 3n all power 3 by 2. Agree? 3 and 3, so it is 1 by 2n. But what about the limit 3n all power 1 by 3n? That is 1. So it is 1 power 3 by 2 equals 1. Therefore, limit 3n all power 1 by 2n is 1 itself. Enough? Limit 3n all power 1 by 3n is 1. This is nothing but a subsequence of limit n power 1 by n. Enough? Limit n power 1 by n equals 1, and we know that every subsequence of limit n power 1 by n converges to 1, but 3n all power 1 by 3n also be a subsequence of n power 1 by n, hence limit 3n all power 1 by 3n equals 1. And limit 3n all power 1 by 2n can be rearranged as limit 3n all power 1 by 3n all power 3 by 2, so it is 1 power 3 by 2 equals 1. Enough. What about limit or consider the limit 1 plus 1 by 2n all power 3. How to find out this limit all power 3? Limit 1 plus 1 by 2n all power 3. So, we know that. What about limit 1 plus 1 by n all power n? That is identity. E, not identity E. Limit 1 plus 1 by n all power n equals E. So clearly, every subsequence of this 1 plus 1 by n all power n should convert this to E. Agreed? Since limit 1 plus 1 by n all power n equals E, therefore every subsequence of 1 plus 1 by n all power n also convert this to E. Enough. Then, what about limit? So consider the sequence. Limit 1 plus 1 by 2n all, consider the sequence 1 plus 1 by 2n all power 2n. That is nothing but a subsequence of 1 plus 1 by n all power n. Therefore, limit 1 plus 1 by 2n all power 2n is again E itself. Why? Because this being a subsequence of this one. Thus, limit 1 plus 1 by 2n all power 3n equals limit 1 plus 1 by 2n all power 2n all power 2n, come on, all power 2n all power 3 by 2. Enough? Yes. So all power 3 by 2, okay, that equals What about this one? That is c. So the required limit is e power 3 by 2. Enough? Yes. So again, find the limit of 1 plus 1 by n square all power n square. Find the limit of 1 plus 1 by n square all power n square. 1 plus 1 by n square all power n square. So we know that this is a non-result. Limit 1 plus 1 by n all power n equals e. So every subsequence of this converges to e. But 1 plus 1 by n square all power n square is nothing but a subsequence of 1 plus 1 by n all power n. So therefore limit 1 plus 1 by n square all power n square equals, yes, it is again e itself. Agreed? Okay. What about limit with respect to n? 1 plus 1 by 2n all power n. 1 plus 1 by 2n all power n. Again, limit 1 plus 1 by 2n all power n be a subsequence of 1 plus 1 by n all power n. What is limit 1 plus 1 by n all power n? That is a itself. So limit 1 plus 1 by 2n all power n is nothing but a subsequence of 1 plus 1 by n all power n. So 1 plus 1 by 2n all power n equals 1 plus 1 by 2n all power 2n. Agreed? All power 2n all power 1 by 2. Sure? 1 plus 1 by n, limit 1 plus, we know that, limit 1 plus 1 by n all power n equals e. Every subsequence of 1 plus 1 by n all power n converges to e. 1 plus 1 by 2n all power 2n be a subsequence. 1 plus 1 by 2n all power 2n be a subsequence of 1 plus 1 by n all power n. Therefore 1 plus 1 by 2n all power n equals 1 plus 1 by 2n all power 2n all power half. What about this? So c, so it is e power half means root e. No? What about the limit 1 plus 2 by n all power n? 1 plus 2n all power n means 1 plus limit 1 plus 2 by n all power n can be rewrite as, this can be rewrite as limit 1 plus 1 by n by 2 all power n by 2 whole square. Enough? Limit 1 plus 2 by n, limit 1 plus 2 by n all power n is limit 1